75 men went to work inside a dam that had been shaking itself apart for 2 years, and every shift manager who read the vibration logs had signed off on running it anyway. At 8:13 in the morning on August 17, 2009, Turbine Unit 2 at the Sayano-Shushenskaya hydroelectric plant in Siberia disintegrated. The rotor, weighing 900 tons, was flung upward. It tore through the turbine hall ceiling like a cork from a bottle. 75 people died. The machine had been announcing this moment for months. Nobody stopped it. This is Fail Point. Tonight's report, Sayano-Shushenskaya. The Sayano-Shushenskaya plant sits on the Yenisei River in Khakassia, deep in the Siberian interior. Construction began in 1963. The plant came online in stages through the 1970s and 1980s. At full capacity, its 10 Francis turbines produced 6,400 megawatts, enough to power a city the size of Moscow. It was the largest power station in Russia, and, for a time, the largest hydroelectric plant in the world. Each turbine unit was the size of a 4-story building. Each one sat at the base of a 245-meter concrete dam, driven by water pressure that could crush steel. The engineering was ambitious. The margins, it would turn out, were not. A Francis turbine works by directing pressurized water through curved vanes onto a spinning runner, the rotor. The runner turns a shaft. The shaft drives a generator. The whole assembly floats on a bearing film thinner than a human hair. It is precise machinery doing brutal work. Every turbine has a danger zone, a band of rotational speeds where the water pressure pulses align with the runner's natural frequency. Engineers call it the forbidden zone. Run a turbine through it briefly and nothing happens. Run it there for hours or days, and the repeated stress accumulates in the metal the way bending a paperclip back and forth accumulates damage. Eventually, the paperclip snaps. So does the turbine. Unit 2 had a history. During its commissioning in the early 1980s, engineers noted it vibrated more than it should. The original turbine design assumed steady, stable water flow, but the Yenisei's seasonal variation was wider than the designers had planned for. Running at partial load, not quite full speed, not quite minimum, dropped the unit into that forbidden zone. The plant operated at partial load constantly because the grid demanded flexible output. Demand changed hour by hour. The turbines were throttled up and down to match it. Unit 2 spent more time in the danger band than any other unit on the station. The logs recorded this, for years. By 2000, Unit 2 had been repaired multiple times. The studs, the bolts that held the turbine cover to its housing, were shearing off regularly. Replacement bolts were installed. They sheared too. The accident investigation would later find that between 2000 and 2009, Unit 2 underwent 47 repair interventions. 47. Each time the unit was restarted. Each restart was authorized by plant management. The authorization records exist. They are unremarkable documents, routine sign-offs, production targets confirmed, shift schedules noted. Nothing in the paperwork reflects alarm. Because within the system's logic, there was no alarm. There was only the grid target, and whether the unit was running or not. Russia's electricity grid had been restructured after the Soviet collapse. By 2009, the plant was operated by Rus Hydro, a state-owned company competing in a liberalized energy market. Power output targets were tied to contracts. Failing to meet them had financial consequences. Shutting down Unit 2 for extended repairs would have required the plant to draw power from elsewhere or reduce contracted supply. Neither option was attractive, so the calculation was made, not once, not by one person, but repeatedly across years, by the system itself. Keep the unit running, log the vibration, schedule the repair later. This is not negligence in the ordinary sense. It is something harder to fix than negligence. In the months before August 2009, Unit 2's vibration readings escalated sharply. The cover bolts were failing faster. In the spring of 2009, the unit was taken offline for repairs. The repair was incomplete. The investigation report noted that 41 of the 80 studs holding the turbine cover were either missing, non-standard replacements, or below specification. The unit was restarted anyway, in February 2009, to meet spring demand. By August, vibration levels were exceeding the safety threshold on every recorded shift. Operators were logging the numbers. The numbers were going up. The unit kept running. The question is not whether anyone saw it. They did. The question is what the system gave them permission to do about it. The morning of August 17, 2009. Unit 2 had been running since the previous day. At 8:12 a.m., vibration sensors on the unit spiked beyond any previously recorded level. The remaining studs, already fatigued, already below specification, could not hold the turbine cover against the upward hydraulic pressure. The cover lifted. Water under 200 meters of head pressure, roughly 20 atmospheres, entered the turbine hall in an instant. The rotor, spinning at 142 revolutions per minute, lost its bearing and was driven upward by the pressure column beneath it. It struck the generator above. The generator structure failed. The ceiling of the turbine hall collapsed inward. 75 people died. Most were maintenance workers in the turbine hall and lower service areas. Many had no warning. The water arrived before any alarm reached them. The plant's automatic shutdown systems did eventually close the intake gates, stopping the flow. But it took over an hour to fully control the flooding. The turbine hall was destroyed. 6 of the 10 units were knocked offline. Russia lost roughly 15% of its Siberian generating capacity overnight. The Yenisei downstream ran gray with transformer oil for days. The environmental damage extended for kilometers. The scale of the consequence was proportional to the scale of the denial that preceded it. The Russian government's technical commission published its findings in 2009. The proximate cause: fatigue failure of the turbine cover studs, causing hydraulic uplift and catastrophic disintegration of Unit 2. The underlying cause: prolonged operation in a high vibration regime without adequate repair. The commission was direct. It found that plant management had operated the unit with known defects. It found that vibration data had been recorded and ignored. It found that the repair completed in February 2009 was inadequate, and that the unit should not have been returned to service in the condition it was in. What the commission was more careful about was the structural pressure that made those decisions feel rational to the people making them. After Sayano-Shushenskaya, Russia mandated new vibration monitoring standards for all hydroelectric plants. Automatic shutdown triggers were required, systems that would take a unit offline without waiting for a human authorization. The forbidden operating zones were written into law, not just engineering guidelines. The plant itself was rebuilt. Unit 2's replacement came online in 2014. The reconstruction cost exceeded 41 billion rubles. The 10 units now carry continuous automated vibration monitoring. If readings cross threshold, the unit stops. The grid has to adapt. That inversion, making the machine's safety the constraint the grid works around rather than the other way, is the real engineering lesson. It took 75 lives to establish it. The hardest failures to prevent are not the ones nobody saw coming. They are the ones where every warning was logged, every number was recorded, every person in the chain understood something was wrong, and the system made doing nothing the path of least resistance. Unit 2 at Sayano-Shushenskaya did not fail silently. It announced itself in vibration readings, in sheared bolts, in 47 repair records. The machine told the truth. The lesson is not to build better sensors. The sensors worked. The lesson is to build organizations where the sensor reading can stop a machine, even when stopping it is expensive. Every failure has a point. Find it before it finds you.